Then what? The plan. Putting an expectation, I was just mentioning you that. Are we coming here with some wish or some objective, right? So, as you all been aware that what we remember hot bed extrusion is nothing but all these three words showing that hot is temperature, melt is melting out, and extrusion means whatever it comes out of that, you know. So the agenda is very simple. We'll go with some of the part production. What sir said that what is the basic. Then we'll go about what is hot bed extrusion. Core subject, that is solubility enhancement. Molecular interaction, what exactly happens. We know about those things, but at the same time, what exactly is happening in a molecular level, that is more important to know for anyone, because we are in the field of research. And then we call as some formulation examples, then screening tools, and then something. In between that, which is very important part is what is that machine which we are going to do it, what is its critical elements, so that you will come to understand. And do not hesitate to ask the question in between if you don't understand something or if you want to know something. It is not necessary.
And at the right time. Okay, so when we talk about effective delivery, it implies the right amount, taking the drug to the right place and at the right time, and this is going to be ultimately resulting in a cost-effective therapeutic clinical application. Also, the delivery systems, they have an increased opportunity today because you can distinguish a drug from competitive threats, because especially in India we know that multiple products of that particular drug. And for the company to make business, to have a business potential there is becoming increasingly difficult, you know, and therefore they have to see that how they can, for a particular drug, bring it to the market in a better way, in a different delivery system, and that is how they will also encash, or there lies a commercial business potential, right? Another aspect is that novel means of delivery, particularly the newer generation carrier systems that we are going to talk about, it allows the branded drugs to be rescued from the abyss of generic competition, right? We know that once a drug becomes generic, the price of the drug hits rock bottom, isn't it? And once the price is hitting rock bottom, obviously the profits that the company is going to make is also coming down, right? And therefore the company is always looking for something that will.
You can come and see. So these are the electrodes. So like this you will pull that. This is for zeta potential. Same holder will be same, only there will not be any electrode attachment. Like this. Okay. So you can put maximum 1.5 ml. Yes. And like your UV, same size will be there. As like your UV, say up to 75% or 2/3 you need to fill with the whatever your sample. And here, accordingly, I will show you how to load the sample in this color. Accordingly, you can put the sample over the zeta potential analysis. So one sample you can put. So now the most important part is your software handling. So everything that you need to do with this software only. Remaining part is same as that of your UV estimation, the preparation of sample and dilution and putting that in a cuvette and in a sample holder, and you have to close that chamber so that there will not be any errors or the deviations from the environmental factors. So that part is over with the actual hardware. But now the remaining part is remain with the software, where you need to handle properly to get accurate results. So here you can see there are three options: size, CG, and the molecular weight. So from here you can select whatever specification or what measurement you need to carry out. Either you have to carry out the particle size or the zeta potential or the molecular weight measurement. So once you select the particle size, here whatever you are observing, that are the size analysis done previously. So whatever previous samples perform, that will come one by one. So here the 100 records automatically get recorded. So here you can see there are around 58 records.
And in the range of -70 to -85 to process over there, and that product we further for freeze drying transfer to this side. So either we can directly keep our product onto this, or otherwise we can directly attach to this product condenser. So at least meanwhile what you can do, other can also see those sensors.
So on and so forth. Then, of course, injectables, right? And liquid orals. So here today we are going to talk only on the first quadrant, that is oral solid dosage forms, and the technology which is going to use for that. Of course, all these 4 quadrants and all the 3 other dosage forms like semi-solids, injectables, and liquid orals are very much important in pharmaceutical dosage forms. But day in, day out, whenever we go to medical stores or the doctors, we always get a prescription of tablets or capsules. So I can say day in, day out, almost 60 to 70 or 80% of the formulations which we take are from oral solid dosage forms. So that's why the share of oral solid dosage forms, unless and until the customer is very critical and you have to switch to injectables, we use maximum times oral solid dosage forms. So today we will discuss about only OSDs. So as I said, what is granulation? This presentation should not be monotonous. Of course, sir will also not like that. So I would like you also to speak in between. Okay. Which, if you have any questions in between, you can interrupt me. We can discuss. There is no hurry. It is not like that I have to cover all the slides within the time period. The basic objective is you should understand what we are delivering and you should gain out of it. Okay. So why granulation is required and what is granulation? So granulation is a process wherein one or more powder particles are combined together with the help of a certain binder to form granule, wherein that granules will have certain flow, and with those granules those granules will have certain flow, and
it also helps during strip packing, during container packing, and also during dispensing. It also helps in improving the surface if we have a subsequent coat. A typical example like what we have here. I used to manufacture a tablet called as Triode. It's one tablet of HIV drug per day. HIV, the dose compliance is very required. The patient has to drug every day, and popping up a pill becomes very, it's not a comfortable for any patient. One who is required to take the tablet every day. So one tablet per day. In this formulations, when we do, it's a bilayer tablet. We found that tablet coating is not easy. So in order to make the surface ready for coating, initially we do a seal coating and subsequently over it we are doing film coating. So we are making the surface ready for film coating through seal coating. As we discussed, we are protecting the tablet from light degradation, we are protecting the tablet from moisture, we are protecting it from getting it degradation because of acidic media and stomach. Also, we are ensuring that our gastric mucosa is not getting impacted because of drug molecule like aspirin.
Now we will start. Once the fluorination is we done this spray time, every time there was some water droplet, that's why that village got wet, so that's why. Powder, thick way to use powder, water content. Generally, it is not we will be remove this pellet and we will add another dry pellet. और मैं ये ऑटोमेशन कितना बड़ा माउथ में रॉकेट साइज का कम हो जाएगा। ये पोजीशन अगर ऐसा रहा तो आपका पेट्रोल का रनिंग बराबर है, आप बैक कर सकते हैं या फिर रिवर्स बटन अगर रिवर्स होगा ये सारा रिवर्स हो जाएगा।
Containing the metal package, particularly tin oxide, which is commercially widely used in worldwide, but it is toxic. According to the approval, the catalyst percentage should be less than 10%, which is very tedious for to making purification. Therefore, if you see any kind of biocompatible, biodegradable polymer, it is too expensive to buy or use for any particular application. Only for a drug delivery system it is affordable. So now our main focus is how we can change this toxic catalyst to the non-toxic catalyst. That is our major goal. And you can see here, like the metal, what the literature reports are there. They are zinc, calcium, zinc, aluminium, and iron, etc. These metals, if you see that pharmaceutical day-to-day life we use, but when it is complex form, so we don't know the nature of the ligand. So because of the ligand, the toxicity arises. So these people, actually the recent researchers, they have actually used those catalysts, but they have not studied the toxicity effect. And some of the complex
thermal analyzer technique is to heat the sample or to cool the sample in a linear fashion. So let us say, for example, 5 degree per minute, 10 degree per minute, and whenever you heat any sample will undergo two different types of property changes, a physical property change and a chemical property change. And both these physical and chemical property changes are very precisely measured in thermoanalytical technique. Okay, so this is a very simple definition. Now look at this slide, very interesting slide. As this technique, DSC and TGA, you can find the applications practically in every field. So if you look at the left hand side, which is polymers and rubber and chemical industry. If you look here at the pharmaceutical industry, food industry and life science industry. What does it mean? It means that thermal analysis technique, DSC and TGA is a very important tool to cater to variety of application, to cater to variety of industries. So under the banner of thermoanalytical technique, there are 4 important technologies are available. I am not going to spend more time on these all 4 technologies. We will be concentrating mainly on TGA, thermogravimetric analyzer, wherein you are measuring a change in mass which is occurring in the sample. So change in mass which is occurring in the sample is directly related with the composition.
Okay. 0.2 seconds sampling, save button. So the first step will be run with the data also saved. The second step 150 to 10 with the 10 degree, maybe I just kept it 5 minutes hold time. This particular step I am not saved. I am not checked the data. So naturally the second step also will be run with machine, but the data may not be saved. Okay. And third step again I taken. So some people what they do is they may be running up to 500 degree from room temperature to 500 degree some sample. They don't want up to 300 data. Up to 300 degree they don't want to data, but they just want to see what is happening. So what they do is first step from 30 to 300 they will give some 20 degree heat rate or whatever it is. They will uncheck the save button. Second step from 300 to 500 with a lower heat rate and they save. So they whatever the portion they really required, that much data they will get. Okay. So like that you can make it n number of steps. Only thing is whichever the step you really require to save, that much you have to save. Okay. Here we are using the nitrogen with the manual flow controller. So the nitrogen we have to make it every time manually. Apart from that, there is an optional mass flow controller which also provided in some cases. There the software itself you can set the flow rate. The machine itself will control the flow. Okay. Here just for information purpose you can put the flow rate of the nitrogen. Otherwise nothing to do with the machine. Okay. So this much will be the temperature program. If you are running with the okay, so this up to this much. Then that one will be the APC condition. The APC condition generally not required to run the sample. Okay, it's a calibration option actually for running the calibration. The APC will be there. The PAD values will be the factory setted, so you supposed to not change anything. Okay. Otherwise, we normally change temperature correction and DSC1 correction. The temperature correction is nothing but, of course, as per Jain sir, we use indium metal standard as a calibration standard. So we taken with indium. First time when we run the indium, we got 150.